All right, class, I'm going to try this out. Feels really strange because I'm lecturing to an empty room right now, but I'm going to try to work out these examples for you. If I'm moving too fast, have the sub pause or rewind, but it's tough for me to tell because I don't have you guys here asking questions. So I'm just going to try to do the best I can. We're going over section 12.4 and 12.5 today. 12.4 is probability. Now, there is a really mathy definition of probability in your book, but to me, an easier definition, probability, is a number describing how likely an event is to occur. And there are many different ways to calculate probability. It all boils down to the basic formula is the probability of an event is equal to the number of ways to get what you want over the total number of possibilities. Now, we have spent a couple of days talking about how to count different things. So sometimes the way to get what you want will be you'll use the counting principle that we learned with the blanks, or you will use a permutation, or you will use a combination. And sometimes the total number of possibilities will either be a counting principle, a permutation, or a combination. So you will use stuff we've learned recently to be able to calculate these two numbers. Now, there are some strange types of probabilities. If the probability of some event E is 0, well, think about that. If you had number of ways to get what you want over number of possibilities, and that equaled 0. So ways to get what you want over possibilities equaled 0, well, there's only one way to divide two numbers and get 0, and so that's the top is 0. So that means there's no way to get what you want. So that is an impossible event. If something has a probability of 0, that's called an impossible event. Some examples of that would be rolling 2 dice and getting 35. Well, they each only have 1 through 6 on them, so the highest you could get is 12. So the probability that you would roll a 35 is 0 because that's an impossible event. Okay, what if the probability of an event was 1? Well, look back at this fraction. If that were to equal 1 instead, then ways to get what you want would have to be the same as the possibilities. So that's a case of an event that must happen. So it's a certain event. Example of that would be the probability that you roll a number less than 13, because the highest you could get is 12, and so anything you roll would be less than 13. Or the probability that the day of the week tomorrow ends in Y. Well, every day of the week ends in Y, so the probability that that's going to happen is 1 or 100%. And then you can have anything between 0 and 1, where not all of the possibilities are what you want, so it's some fraction of it. And so it's usually given as a fraction or as a decimal or a percent. So let me just do some examples. Okay, example 1. Says a bag of candy has 12 red, 11 yellow, 5 green, 6 orange, 5 blue, and 16 brown candies. These must be M&Ms or something. Okay. What is the probability that if you choose at random that you will choose a yellow one? So I'm going to ask you 2 questions. What is the probability you choose a yellow piece of candy at random? Secondly, what is the probability you don't choose a yellow one? Okay, so the first one, remember back to our probability formula. The probability of a yellow one is number of ways to get what we want a yellow one, over total possibilities. Well, if you add these up, there are 55 pieces of candy. So the total possibility is 55. Now, how many of those are what we want, which is yellow? Would be 11. And then that's just a fraction that you simplify. 11 goes into both of those, and you get 1/5. So the probability that you get a yellow piece of candy would be 1 out of 5, which that means a couple things. That is a percent, would be 20%, so you could say you have a 20% chance of pulling one yellow. That also means that if you picked out 5 pieces, on average, one of them would be yellow, okay? So that 1/5 means if you did this 5 times, on average, one of those would be yellow and the other ones would not be, okay? So the answer to that would be 1/5. All right, now let's look at the next one. What's the probability that you don't choose a yellow one? So that's probability that it's not yellow. Well, there's still 55 total pieces. How many of them are not yellow? Well, if 11 were, then there are 44 that are not. And that reduces to be 4/5. So you got a 4 out of 5 chance of doing one that is not yellow, okay? What do you notice about these 2 probabilities? If you added them together, so this is the answer to the 2 questions, but I'm going forward to teach you something else. If you add those together, 1/5 plus 4/5, you get 5/5, which is 1. Anytime you have 2 things that their probability adds up to 1, they are called complements, okay? And complementary events are two events are complementary if together they cover all possible outcomes. So if you look back at this, the 2 events, drawing one that's yellow or picking one that's not yellow. Well, every piece of candy in there is either yellow or not yellow. So those 2 events together cover everything. So they are called complements. So let me give you some events and let's talk about what the complement would be. Okay, what if the event was rolling an even number on a single die? Okay, well, the complement would need to include everything that is not that. So that would be rolling an odd number, because together that covers everything. All right? What if the event was picking a student at random and the student is male? Well, the complement to that would be all the other outcomes, so it would be student is female. Okay, let's do one more. What if the event was rolling a 6 or higher on 2 dice? Well, we need to include everything that is not 6 or higher, so that would be rolling 5 or less. Okay? So in each case, if you put those together, that's all the possible outcomes. And if you added the probability of this and the probability of this, you would have to get 1, because that includes everything, and the probability that everything could happen is 1, because you cover all the possible options. All right? Let's do another example. Suppose Miguel draws 5 cards from a standard deck what is the probability that his hand contains 2 cards of one suit and 3 cards of another suit? Okay, now this one's pretty tough, okay? First of all, let's find out, remember the probability is ways to get what you want over total possibilities. Okay. Some of you may need a refresher on what a standard deck of cards is. It's 52 cards. There are 4 suits with 13 cards each. And those are hearts, diamonds, clubs, not good at drawing this, and spades. Maybe. Okay. Then those are ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king of each one. Hearts and diamonds are red. Clubs and spades are black. Okay. So first let's figure out just how many hands there are. Well, that is going to be a combination, because it doesn't matter what order you get the 5 cards, it would still be the same hand. So that is the combination of 52 choices, and you're going to pick 5 of them. Okay? So that's the combination of 52, choose 5. All right, if you'll remember back to your combination formula, that equals 52 factorial over 52 minus 5 factorial 5 factorial. Well, that is 52 factorial over 47 factorial, 47 factorial, 5 factorial. Well, biggest on the bottom is 47 factorial, so that's where you're going to stop. So you got 52 times 51 times 50 times 49 times 48 times 47 factorial over 47 factorial times 5 times 4 times 3 times 2 times 1. 47 factorials cancel. 5 goes into 50 10 times. 4 goes into 48 12 times. 3 goes into 51 17 times. And 2 goes into 52 26 times. So you're left with 26 times 17 times 10 times 49 times 12, which is let me grab my calculator. 26 times 17 times 10 times 49 times 12. That is 2,598,960. So that's how many 5-card hands there are. So that's how many total possibilities there are. Okay? So, now we're going to figure out how many ways you can get 2 cards of one suit and 3 cards of another suit. And that's going to be the top of the fraction. Well, first thing is we have to pick which 2 suits there are. Okay? So first you're going to, and the order matters because you got to get 2 of one and 3 of the other. So it matters which ones are in the 2 and which ones are in the 3. So that's a permutation. We have 4 suits to choose from, and we're going to pick 2 of them. Okay, so just choosing which suits there are this many options, which, you know, is 4 factorial over 4 minus 2 factorial. 4 factorial over 2 factorial, which is 4 times 3 times 2 times 1 over 2 times 1, which is 12. So there are 12 ways to pick this suit than that suit. Then, once we've chosen the suit, how many 2 cards can we get? Well, we have 13 cards to pick from in that suit. So this says we've chosen which suit is here and which suit is here. The order matters. Now, we've chosen the suit. We want to know what's the probability that we get 2 cards out of it. Well, that's a combination because it doesn't matter which order we pick those 2 cards. We've already chosen the suit, so that means we have 13 cards to pick from in that suit, and we're going to pick 2 of them. Well, according to the formula, that is 13 factorial over 13 minus 2 factorial, 2 factorial. So that's 13 factorial over 11 factorial, 2 factorial. So that's 13 times 12 times 11 factorial over 11 factorial times 2 times 1. Those cancel, and 2 goes into 12 6 times, and 6 times 13 is 78. So there's 12 ways to choose the suits. And after we do that, we want 2 cards of the first suit. Well, there's 72 ways for that. Then, how many ways can we get 3 cards of another suit? Well, that's a combination. It's a different suit, so there's 13 to choose from, and we want 3. Well, that is 13 factorial over 13 minus 3 factorial, 3 factorial. So that is 13 factorial over 10 factorial, 3 factorial. 13 times 12 times 11 times 10 factorial over 10 factorial times 3 times 2 times 1. Those cancel. 3 goes into 12 4 times. 2 goes into 4 2 times. So that's 13 times 11 times 2. And it is 286. So there's 286 ways to do that. So for each two suits you choose, there are 78 ways and 286 ways. And remember I told you that and always means multiply. So we're going to do 12 times 78 times 286. And we get 267696. Okay? So there are that many ways to get what we want. There's that other huge number of possibilities. So the probability is number of ways to get what you want, which we just found out was 267696 over total possibilities, which is 2598960. And I am not going to be cruel enough to make you reduce that fraction. I would just make you get a decimal because we are going to be using a calculator, so that's about 0.103. So that means you have about a 10% chance of that being the hand you drew. Okay? Let's try one more of those. Okay? Let's see. So let's say that you are choosing a 4-person committee from a group of 8 guys and 10 girls. And you're just going to choose it at random. You're going to put the names in a hat and draw them out. What is the probability that it is 2 guys and 2 girls? Okay? So, this is example 3. So, first thing to ask yourself, is this going to be a combination or a permutation? Well, it's a combination because it doesn't matter what order you pick them. You just want 2 guys and 2 girls. So, first thing we need to do is know, so remember, probability is number of ways to get what you want. So to get 2 guys and 2 girls. And then on the bottom, it's total options. So the bottom one's easy. How many 4-person committees are there when there are 18 people? So that's just the combination of 18 choose 4, which according to our formula is 18 factorial over 14 factorial 4 factorial. Okay, which is 18 times 17 times 16 times 15 times 14 factorial over 14 factorial times 4 times 3 times 2 times 1. Those cancel. 4 goes in there 4 times. 3 goes in there 5 times. 2 goes into 18 9 times. So that is 9 times 17 times 4 times 5. So there are 3,060 possible committees. So we need to know how many of those have 2 guys and 2 girls. Okay? So first we need to figure out how many ways can we choose two guys. And, because we need them both happen, ways to choose two girls. Well, it doesn't matter the order, so it's a combination. If we're choosing two guys, we have 8 to choose from, and we're going to pick 2. And for girls, if we're choosing 2 girls, we got 10 to choose from, and we're going to choose 2. So this is 8 factorial over 6 factorial, 2 factorial. This one is 10 factorial over 8 factorial, 2 factorial. So this becomes 8 times 7 times 6 factorial over 6 factorial times 2 times 1. Those cancel. 2 goes into 8 4 times. That's 4 times 7, which is 28. This becomes 10 times 9 times 8 factorial over 8 factorial times 2 times 1. Well, those cancel. 2 goes into 10 5 times. 5 times 9 is 45. Now remember I told you with probability, and means multiply. So the probability of this and this is 28 times 45. The total ways that this happens, because you have this many ways to choose guys, and for every one of those you have this many ways to choose girls. So it's 28 times 45, which is 1260. So the probability is there are 1260 ways to get what you want over there were 3060 options. Now that's a fraction that's manageable, then you can reduce. You can divide them both by 10, you get 126 over 306. You could divide both of those by 2, and you would get 63 over 153. Okay, and then I think that 3 goes into both of those. 3 goes in there 21, 3 goes in there 51. 3 goes into both of those, 7 and 17. So that's your answer. You have a 7 out of 17 chance of choosing a committee that is 4 guys and 4 girls. All right, that is it for 12.4. Let's move on to 12.5, which, don't worry, it's much simpler. And that is multiplying probabilities. We've already been doing this when we were multiplying options, when we were counting how many different ways you could do that. Well, it just extends to probabilities. If you want the probability that A and B happen, so one event and another event, well, it is defined as the probability that A happens times the probability that B happens if A has already happened. So probability that A happens and B happens is the probability that A happens times the probability that B happens if A has already happened. Now, that may be a little confusing to you, but we have 2 types of events. We have independent and dependent. Independent events, if one occurs, the probability that the second occurs is not affected. Dependent is that it is affected. Okay? Let me give you some examples. Okay? Let's say that I'm selecting a student at random, and A is the student has a summer birthday, and B is student is female. Well, those would be independent events. Whether or not the student has a summer birthday has no effect on whether or not the student is female. Okay? But let me give you two that are dependent. So these would be independent. Dependent would be A, student is female, and B, student is 5'6" or shorter. Well, if the student you chose is female, the likelihood, the probability that the student is 5'6" or shorter is going to change than if the student you chose was not female, because females are more likely to be this height or shorter, because on average guys are taller. So these would be dependent events, because whether or not A happens changes the probability that B happens. So back to here, when you're given this formula, the probability of B given that A already happened, if they're independent, it doesn't matter. That's just the probability that B happens, because A had no effect. But if they're dependent, then you've got to assume A happened and find the probability of B. Okay? So let's look at a marble example. So let's say there are 6 red, 5 black, and 1 yellow marbles in a bag. What is the probability that if you draw 2 marbles without replacing the first, that they are both red? Okay, so we have 2 events. We have the probability that the first is red. Well, we have 2 events. The first event is that the first is red. The second event is that the second is red. And we want this and this to happen. So since we want and, we've got to do the multiplication. So it's the probability that the first is red times the probability that the second is red if the first was red. So what's the probability that the first one you draw is red? Well, there are 12 marbles in there, so there are 12 options, and 6 of them are red. Times probability that the second is red if you already pulled out a red one. Well, if you've already pulled out a red one, there are 11 marbles in there, and 5 of them are red, because you took one out, so it's 5, 5, and 1. So probability that you pull a red one out now is there are 5 to choose from, and there are 11 in the bag. So you just multiply these two. Well, that is 1/2 times 5 over 11, which is 5 out of 22. And that's your answer. Okay? Let's do one more of those. So let's say that you have a spinner and it's labeled 1, 2, and 3, and then you have a 6-sided die with the numbers 1 through 6. So let's say that you spin the spinner and you roll the die. What is the probability that both are odd numbers? Well, so the two events is that the spinner is odd and that the die is odd. And we want them both to happen, so it's an and. So the probability is the probability that the spinner is odd times the probability that the die is odd given that the spinner already was. Well, those are independent events. Whether or not the spinner is odd has no bearing on whether or not the die is. And that's different from here. Whether or not you picked out one red changes the probability that the second one is red. So those are dependent. These are independent, so we don't even have to worry about it in the second one. It's just the probability that this times the probability of this. Well, the spinner, there are 3 options, and 2 of them are odd. So the probability is 2 out of 3. Times, here, probability that the die is odd, there are 6 sides, and 3 of them are odd. So you just multiply that, and it's 6 over 18, which is 1/3. So the probability is 1/3. Okay, the last thing I need to go over is actually something that I realized I skipped in 12.4, and that is the odds of something happening. Okay, so let's say that you roll one die, sorry. I feel like it should be called dice, but it's not. Okay, so you roll one die, you could get the numbers 1 through 6. So what is the probability that you get 3 or higher? Well, if you'll remember, probability is ways to get what you want over total possibilities. Well, there are 6 options. 1, 2, 3, 4, 5, and 6. How many of those are 3 or higher? 4. So it's 4 out of 6, which is 2 out of 3. So you would say that the probability is 2/3, or you have a 2 out of 3 chance. Well, there's also something called odds. And odds are just another way of expressing probability. Probability is number of ways to get what you want over number of ways, number of total possibilities. Odds are number of ways to get what you want over number of ways to not get what you want. So what if I ask you the odds of rolling a 3 or higher? Okay, well, number of ways to get what you want is 4. There are 4 ways to get what you want. Over how many ways can you not get what you want? Well, that would just be these 2. There are 2. So 4 over 2 is 2 to 1. So you would say that there are 2 to 1 odds that you will get a 3 or higher. Okay? So the last way that works is the probability. This is the last example. I forget what number we're on. Probability that an event happens is 4 out of 7. What are the odds that it happens? Okay, so that means there are 4 ways for it to happen over 7 possibilities. So how many ways could it not happen? That means there are 3 ways it doesn't happen. Because there are 4 ways for it to happen, there are 7 options, so 3 don't work. So the odds, remember, are ways for you to get what you want, or ways for it to happen, over ways for it to not happen, which is 3. So you would say it has odds of 4 to 3. All right, hope I didn't go too fast. I will answer your questions on Friday. but your sub now has the homework for you. Thank you all.